The open sea. Turbulent, violent, unceasing, ruthless. But this is a ship's natural home. So a ship out of water is a ship away from home. All ships need docking at some time in their careers. But any ship, and especially a wooden ship, finds her true place in her true environment, the sea, fully supported in the medium for which every plank and spar, bolt and brace of her was designed. So what happens when you must keep Britain's most famous warship docked to shore, century after century?
Well, one of the things we've been doing over the past 40 years is measuring the way in which the ship moves, and we've now got very compelling data that she's slowly falling in on herself at the rate of about half a centimetre a year. So as the top decks get closer to the keel, the ship's bulging, and that's causing the structure to become a little unstable. Clearly we can't go on doing that forever, and the other big problem is that it opens up the ship's sides and decks and allows water in. Rainwater causes rot, so she's becoming unstable through this process.
All that meant the need was clear and urgent. What wasn't immediately clear was what should replace the giant cradles that have held Victory in position since the 1920s. And before even deciding that, where they should go and how they should relieve the stresses that have built up on the great ship's hull over the last century.
The first stage was to undertake some computer modelling of the ship, and for that we needed to undertake laser scanning to give us an accurate model. We actually took 89.25 billion measurements to give us that model. That was then passed over to the structural engineers, who have pulled it apart and played with it and looked at the loadings on the ship and the way that she's supported, and have been able to apply the various loads that you have on the ship, people going round, the dead weight of the hull, the wind, rainwater falling onto her. All those loadings have been applied to the model to give us the answer of why is she moving. And then, if you know why she's moving, you can begin to look at mitigating that movement. And that's how we arrived at 2 lines of props on each side of the keel, and a total of about 136 props, giving us the support we need for long-term care of the ship.
Enter consulting structural engineers Fenton Holloway. They specialise in analysing unusual structures like Victory.
We looked at the way that the internal ship structure was made. Within the hull there are some very large timbers called riders, and they're enormously stiff. They carry a lot of the ship load. So it became apparent that our placing props directly under those riders would be picking up a lot of the load. And we found that by propping those particular points and then producing an even distribution of supports between those points gave us the optimum support condition. So the solution that we've come up with allows for us to support the ship with 136 props in 2 lines and 4 transom props at the stern.
To fabricate the props, experience in vintage and veteran shipwork was vital. ML Engineering had already proved themselves with the restoration of the submarine HMS Alliance and with the conservation of the big gun monitor HMS M33, last surviving ship of the Gallipoli campaign.
It's quite a challenge, but once the prototype's done, then we're looking at about a 6-week turnaround of each one to site and fitting.
Each prop is designed to take about 15 tonnes each, and it will vary throughout the length of the ship. They are capable of taking 30 tonnes each, so we can actually take out a prop if we need to replace some planking or redistribute the load. They're telescopic, and in fact they've got a load cell at the bottom, and we can monitor the load on the prop all the time, 24 hours a day. The idea is if the load does vary at any time, because maybe the planking is moving or the ship is moving, we can actually locate which prop is a suspect, and we can come down and readjust it and put the load back or repair the ship in that area.
The BAE and ML team had to have a care not only for Victory, but also for the dock in which she is berthed. This too is of great historic and heritage importance as the oldest dry dock in the world.
We're going to increase the load from the 10 tonne on the prop up to 20 tonnes. And we're just doing a quick test for 20 tonnes over about a 30-minute period before we remove the prop and move it to a third test position up higher in a different bay. We're hoping to see that there's no movement, or not a great deal of movement, in the ship's hull, so we're not damaging the timbers of the actual hull of the Victory, and we're not damaging any of the dock blocks down below if we can go up to 20 tonnes.
The new support system for Victory must not only be strong, it must also be very accurately sighted. A laser theodolite is used, quite literally pinpointing the precise positions in which, one by one, the new supports must be placed. Each one can be individually adjusted once installed, and each one has a load cell monitoring the pressure on the hull, continuously feeding information to the National Museum. Loadings will be closely monitored to keep just the right pressure on Victory's hull at all times.
Fundamentally, we have an awful lot of work to undertake with about 30 million pounds worth of conservation work that is required by the ship's hull. We can't do that until the hull is stable and stops moving. That's the critical aim of the new support system. Stop the ship moving, get her in a stable condition, and allowing us to move on to undertake the necessary work of conservation to ensure that the hull is here for the next 250 years.
So, another victory for HMS Victory, and as England would only expect, a safer berth for the Navy's greatest warship.